Dear students, welcome to Ideal Adarsh Native Coaching Center. All the best for all students coming in 2021. Okay, I am Raghuram. I can deal chemistry subject. I have more than 12 years experience in NEET and JEE mains. Okay, what about chemistry subject? Chemistry is very easy subject when you learn the basics. If you learn the basics, chemistry easy subject. Okay, so in NEET also, if you prepare well, properly prepare, properly practice, easily 140 marks cross in NEET exam. Okay, all the best for students. Okay, today we have to discuss 11th portion, 11th class portion, structure of atom. I think already all of you knows the basics in your 11th and 12th class. Once again, we have to recall the basics, structure of atom basics. Okay, first of all, what is the atom? Atom, what obtained from atomio. Atomio, it is the Greek word. It is the Greek word. Atomio means non-divisible particle. Non-divisible particle. Okay, old scientist up to 18th century, John Dalton and other philosophers assumed that atom cannot divisible. Okay, but later 19th century, many scientists research on atom. Finally, they can conclude atom can divisible. So, in 19th century, many scientists research on atom. Finally, they conclude atom can divisible as a particles. As a particles like electrons, protons, neutrons, positrons, neutrinos. Then another subatomic particles also there. So atom can be used as a subatomic particles. Subatomic particles as electron, proton, neutron, positron and neutrinos. This is the common introduction. Then if you go to one by one, the discovery of electrons. Discovery of electrons. Okay. So electrons discovered by J.J. Thomson. J.J. Thomson discovery by electron discovery by J.J. Thomson by using one charge tube, that is he called cathode ray charge tube. Charge tube means already you studied in 12th chemistry, electrochemistry chapter. What is charge tube? Charge tube having two ends, one end having cathode electrode, another end having anode electrode. Whenever electric current supplied to the tube, so ions or electrons moving from one place to another place. So already he knows in electrochemistry. So J.J. Thomson also select cathode ray charge tube. Cathode ray charge tube. Cathode ray charge tube. Okay. So this is cathode ray charge tube. This is cathode. Left side cathode electrode is select negative side. Right side you can select anode electrode. It has positive charge. So he apply only low pressure. Only apply low pressure. This is vacuum. Then he can supply high voltage current. High voltage current. Okay. J.J. Thomson, he took the cathode ray discharge tube. It has two ends. One end having cathode electrode, right side end having anode electrode. He can apply only low pressure to the cathode ray tube and he can supply high voltage current to the cathode ray tube. So what he observed? So J.J. Thomson, what he observed? What he observed? What he observed? Whenever high voltage current supplied to this discharge tube, some rays produced at the cathode and can move towards anode. Can move towards anode. Okay, some rays produced at cathode and can move towards anode. Can move towards anode. Okay, that is J.J. Thomson observed. Okay, then what are the characteristics of these rays? So starting, he called cathode rays. Why he called cathode rays means these rays produced at cathode can move towards anode. So characteristics, what he observed characteristics. First of all, if absence of electric and magnetic field, if absence of electric and magnetic field, these cathode rays can move in straight line. So cathode rays can move in straight line. Okay, what is the first application? Whenever J.J. Thomson, if you do electric and magnetic field absence, if absence of electric and magnetic field, these cathode rays can move towards anode in straight line. Okay, this is the first one. Next, second one. Second one is very important point. Okay, if you apply, second point very important. In presence of presence of electric field, these cathode rays deflection move towards anode direction or right side. Okay, in presence of electric field, these cathode rays deflection means what is the meaning of deflection? Bending, not straight line, bending. So in presence of electric field, these cathode rays deflection and move towards anode. This is the important one. Okay, before, if absence of electric and magnetic field, these cathode rays cannot deflection, can move in straight line. Whenever we can apply or in presence of electric field, these cathode rays deflection means bending and move towards anode. This is the second point. Next, third point. What is observed? Third point. In presence of magnetic field, very important. In presence of magnetic field also, these cathode rays deflection and move towards south pole. Okay, deflection like that. So in presence of magnetic field also, these cathode rays deflection and move towards south pole. This is important. Okay, here very important 3 points, very important point. First one, in present, if absence of electric and magnetic field, cathode rays cannot deflection, just move in straight line. Okay, second one, in presence of electric field, cathode rays can move towards anode direction. Third one, in presence of magnetic field, cathode rays deflection can move towards south pole. Electric field means deflection, move towards anode. Magnetic field means deflection, move towards south pole. No electric field, no magnetic field means can move in straight line. Okay, these 3 points are very important. Okay, finally final conclusion. Okay, where is cathode rays producing at cathode? Cathode electrode having what charge? Negative charge. After producing cathode rays can move towards anode. Anode what charge having? Positive. Generally, which charge particles move towards anode? Negative charge particles. That's why finally conclusion, cathode rays having negative charge okay, is called electrons. Okay, this is the observation by J.J. Thomson in discharge tube. Next, here another important point. depending. This is the cathode ray tube. Next one. So by using cathode ray tube, we have to find out the electrons and electron charge in presence of electric and magnetic field. How does their direction change? Next one. J.J. Thomson find out charge to mass ratio of electron. Charge to mass ratio of electron experimentally. What is that value? 1.7588 into 10 power 11 coulombs per kilogram. This is the experimental value for charge to mass ratio of electron. Okay, experimental value. After that, this experimental value. Another scientist, Millikan, find out charge of the electron. Find out charge of the electron. So this is also experimental value. That value 1.602 into 10 power minus 19 coulombs. This is the charge of the electron experimentally found out by Millikan. This is the charge to mass ratio of electron experimentally found out by J.J. Thomson. Okay. Next one. Find out the already we know charge to mass ratio value by J.J. Thomson, charge value of electron by Millikan. Now we have to find out mass of the electron. Okay. Mass of the electron. Here E by M. Here E means charge. Already know charge of the electron. M means mass of the electron. E means charge of the electron. Already we know. Right. How do you find out mass of the electron? Okay. E by M value J.J. Thomson how much given amount? E by M equal to 1.7588 into 10 power 11. Next, E value how much given Millikan? 1.602 into 10 power minus 19 coulombs. Here, coulombs per kilograms. Already experimental values given. That's why 1.7588. Otherwise, directly find out mass equal to charge of the electron. E means charge of the electron by charge to mass ratio of the electron. Okay, charge of the electron by charge to mass ratio of the electron. What is the charge of electron? 1.602 into 10 power minus 19 coulombs. Charge to mass ratio of electron how much? 1.7588 coulombs per kilogram. Okay. Here coulomb cancel. Finally we got 9.18 into 10 power minus 31 kilograms. This is the mass of the electron. How do you find out mass of the electron? Already Thomson given charge to mass ratio value. Next, milligram given, charge of the electron value. So easily find out mass equal to charge by charge to mass ratio. So we got this value 9.18 into 10 power minus 31 kilograms. This is the mass of the electron. Next, Thomson given another formula for charge to mass ratio. This is simple formula. With respect to hydrogen atom, charge to mass ratio, charge to mass ratio with respect to hydrogen atom. Okay, with respect to hydrogen atom, E by M equal to magnitude of charge. That means whether positive charge or negative charge. Magnitude of charge and by relative mass. Relative mass. This is one formula with respect to hydrogen atom. Okay, one question. What is the charge to mass ratio of alpha particle with respect to helium atom. With respect to helium atom. With respect to hydrogen atom. With respect to hydrogen atom. With respect to hydrogen atom, charge to mass ratio equal to magnitude of charge by relative mass. Okay, here alpha particle means helium. Alpha particle means helium 4. Okay, this is the alpha particle. Charge is 2. That means answer here, answer E by M equal to what is formula? Magnitude of charge. Alpha particle charge plus 2. Alpha particle charge plus 2. Okay, 2 by mass. So alpha particle mass, alpha particle equal to helium. Already nuclear physics knows. Alpha particle equal to helium. So mass of the alpha particle 4. So 2 by 4 equal to 1 by 2. Here 2 means alpha particle charge plus 2. Alpha particle charge plus 2. 4 means mass. Alpha particle equal to helium. So helium mass already knows 4. 2 by 4 equal to 1 by 2. This is the charge to mass ratio with respect to hydrogen atom. This is about electron. Next one, proton. These are also called anode rays or canal rays. Okay. Here experiment not in your syllabus. So anode rays also experiment will be doing in cathode ray discharge tube. Just characteristics see. Anode rays having positive charge. Next, another important point. Anode rays nature of the gas and nature of the material, in cube. Okay, these anode rays experiment done by or protons discovered by important point. Protons discovered by Goldstein. Who is the name? Goldstein. So anode rays or protons discovered by Goldstein. So generally it having positive charge. These rays in discharge tube depends on nature of the gas and nature of the materials used in tube. Before cathode rays does not depends on nature of the gas and does not depends on nature of the material used in tube. Okay. Next, protons charge. What is the charge of protons? So, even protons charge value, experimental value. Protons charge value equal to 1.2 plus 1.602 into 10 power minus 90 coulombs. Next, protons mass. Proton mass equal to 1.2673 into 10 power minus 27 kilograms. Now, what is the charge to mass ratio of proton? Very important point. Charge to mass ratio of proton. Okay, E by m value of proton. Right. What is the E value? E by m value of proton equal to 1.602 into 10 power minus 19 coulombs by 1.673 into 10 power minus 27 kilograms. If you calculation, we get experimental value 9.58 into 10 power 7 coulombs per kilograms. This is the E by m value for the proton. Experimentally we did. Okay. Next step. Here important point amma. Proton and electron. Proton and electron. Which EMI value, E by m value, which E by m value, larger. Previous question, proton and electron, which E by m value larger? Simple one amma. So, electron mass more than proton mass. Okay, sorry, electron mass very less than proton mass. Okay, that means compared to proton mass, electron mass is negligible. Understand now? Compared to proton mass, electron mass is negligible. Okay, that's why E by m value. M means mass. Denominator value very less means total value automatically more. Understand now? Here m means mass. M is the denominator. Whenever electron mass compared to proton mass, very negligible. That's why. So here mass is the denominator value. value. Proton E by m value. What is the reason? Already I given. Proton mass more than electron mass. Not only more than mass. Whenever electron mass compared to proton mass, negligible, very small. That's why electron E by m value more than proton E by m value. This is one important point. Next one, electron E by m value does not depends on nature of the gas and nature of the material. But proton E by m value depends on nature of the gas and also depends on nature of the materials used in cathode ray tube. But electron E by m value does not depends on nature of the gas and what material used in the discharge tube. These 2 points are theoretical questions. Important one. Finally, neutrons means already knows. Neutrons discovered by Chadwick. Scientist discovered neutrons has neither positive charge nor negative charge. Neutral charge. Neutrons having neutral charge. No charge. This is about the neutrons. Okay. Just we do the table. Electrons, protons, neutrons. First one, charge value, relative charge, mass, relative mass, E by m value. Right. Electron's charge value 1.602 into 10 power minus 19 coulombs. Relative charge minus 1. Mass 9.1 into 180 approximately. Okay. 10 power minus 31 kilograms. Relative mass. Here electrons relative mass very less. Very less. Just to write very less. E by m value 1.78588 into 10 power 11 coulombs per kilograms. Next, protons, same chart. 1.602 into 10 power minus 19 coulombs. Relative charge plus 1. Mass 1.673 into 10 power minus 27 kilograms. Relative mass plus 1, approximately plus 1. Okay, E by m value 9.58 into 10 power 7 coulombs per kilograms. Coulombs indicate charge. Neutrons charge? No. Neutrons relative charge? No. Because neutrons are neutral charge. Next, mass of the neutrons 1.65 into 10 power minus 27 kilograms. Relative mass, this is also approximately plus 1. E by m value no charge now. That's why E by m value not having. This is about electrons, protons and neutrons. Okay, this is today basics. Generally these are basics only. Just one time recall. 5 minutes daily